In this session, I will explain about the mobile charger types. Basically, if we consider the block diagram of a mobile charger, it consists of the first block, which is nothing but step down transformer. The input is AC here, 230 volt, and that has been stepped down to 12 volt by making use of a step down transformer. This is applied to another block, which is called as a AC to DC converter. Usually the circuit which is used in this is a bridge circuit, which will convert the AC, that is 12 volts, into its equivalent DC value. Once we get the DC value with plus and minus notation, here there is no polarity, because AC during first half cycle, if this is plus and this is minus, during next half cycle this will become minus and this will become plus. So polarity is not shown to the AC waveforms. Whereas if we consider the DC, there is plus and minus terminals on the output side. So after bridge circuit, the next circuit which is required is called as filter circuit. The function of this filter is to remove the AC components present in the bridge rectifier. This AC to DC converter is not a pure DC converter. It contains some AC components which we call it as ripples. So these are removed by making use of filter. Usually capacitor is used for making use of filters, and these capacitors may be connected in different forms so as to form the filter section, and it may be connected in pi section, or different arrangements can be used here. Then this should be given the output which is obtained now. If we consider the waveform also here, this is input which is AC, which has been stepped down here to 12 volts, and this is converted into DC here across these two terminals. Then the function of filter is to remove the ripples and make this almost constant, that is DC, by charging and discharging function. Then after this voltage has to be maintained constant, and that can be used or done by making use of regulator circuit, and the output of this will be the required voltage that we require, that is 5 volts. Now the circuits can be changed based on how we make use of the components. So this AC to DC converter bridge rectifier, we can make use of 4 diodes which are of BY127, and step down transformer, we know it is 230 volts to 12 volt transformer, and 4 such BY127 diodes can be used to form the bridge rectifier circuit. And filter, for this filter circuit we can make use of 1000 microfarad 12 volt capacitor, single one, and this regulator we can make use of 7805 IC, voltage regulator IC, which will provide 5 volt constant at its output. But the problem is, if we construct a circuit in this fashion, the physical appearance of these diodes is very large, and the size of the charger will increase if we consider this and this. So the other method is to make use of a 230 volt 12 volt transformer, and instead of using BY127 we can use 1N4001 or 4007 diodes, 4 such diodes to form the bridge rectifier, and this we can make use of 1000 microfarad 12 volt capacitor only. And for this regulator we can make use of Zener diode, which operates in the reverse biased mode. Up to this we have discussed in the last session. Now I want to tell how we can have this regulator using Zener diode. So this is the supply voltage that we are getting here. We can call this as Vs as the input of the regulator, and across the load resistor we can take out the output, that is 5 volt DC, and this is how we have to connect the components. And to connect this we can make use of 100 ohm resistor here, and we can use a Zener which may be rating from 5.1 to 5.6 volt here, which can provide that much voltage, and this will provide constant 5 volt at its output, even though there will be slight variation in the output. So Zener diodes can have different values, and this that can be selected maybe around 500 ohms. So these values can be changed based on how much voltage, how much current rating we require at the output side. And this voltage, if we take it as 12 volts, then this may be the circuit diagram. And the current IS which is flowing in this RS is given by Vs minus Vz divided by Rs. Vs is this voltage minus Vz is this voltage divided by the resistance Rs. That will give the current flowing through the circuit, because this voltage and this voltage will be the same. This voltage will be equal to summation of the voltage drop across here and the voltage drop here. So VL is this voltage, and that will be equal to this voltage, that is Vz. So VL equal to Vz, that is equal to 5 volts, whereas Vs equal to, if we consider Vs, that will be equal to Vz plus the voltage drop across this, if I take this as V only. So based on these equations, one more equation is given, that is IL. IL is given by this IL current, load current, that is given by Vz divided by RL. I is V by R, so V is nothing but Vz. This voltage is 5.6, it will be 5.6 divided by the resistance of this. So based on that we can calculate the different currents, and we can use this circuit as the regulator circuit. By knowing the different values, what is the current required and all, we can implement this circuit. Thank you.